Morning everyone, welcome to this little tute on analysing reducing balance loans with recurrence relations. We'll kick it off with just familiarising ourselves, or hopefully re-familiarising ourselves with some of the terminology that we use. So when we talk about the word balance, we want to remember that that's purely referring to the amount that's owed on the loan. This will obviously change over the life of the loan. The principal is the initial amount borrowed. Okay, so you take out a loan for $5,000 to buy a car, then your principal is $5,000. And probably the newest one for most of us is the reducing balance loan, which is a compound interest loan with regular repayments that is generally repaid in full over the life of the loan. Okay, so there are our key terms that we want to be familiar with as we move through this. Our model for this is pretty much identical to what we saw in combining geometric growth and decay, and that's looking at V0 is the initial sum or the initial quantity. In this instance, V0 is our principal, okay, and then our recurrence relation is R times Vn minus D, where D is the amount that we pay off the loan every month, quarter, week, whatever it might be. R is the rate. We should be familiar that the rate is whatever the percentage rate given to us by the bank, divided by 100 and add 1 to that. So if we're paying 5% interest on a loan, then our rate will be 1 plus 0.05, which gives us an R value of 1.05. Alright, so we'll dive straight into an example for this. I think it might be the easiest way to run through it. It's, like I've mentioned, pretty much pretty similar to combining geometric growth and decay. So you look at that. If you borrow $1,000 at 15% compounded monthly and repay $257.85 a month for 4 months. Okay, we want to run through firstly stating the recurrence relation. So the recurrence relation should look like this with our, change the colour of my pen, with our V0 equal to 1,000, and then Vn plus 1 will be equal to our R value. Now R, throw this up here, R is going to be equal to 1 plus the rate of interest, which is 15%, divided by 12 because it's monthly, over 100. Alright, so if we divide that, we get a figure of 1 plus 0.0125. Alright, so our R value is going to be 1.0125. 15% divided by 12, and then that figure's over 100. So continuing with our recurrence relation. Okay, sorry about the long pause there. I thought I hit pause, whereas I let it run. So that last 4 cents, we'll skip over to the new page, and we need to deal with that last 4 cents. So what will happen is that instead of that last payment being the $257.85. The last payment we will add 4 cents to. So instead of $257.85, we will add our 4 cents to the very end. That'll mean the last payment is effectively $257.89. Okay, and that means that we still satisfy our 4-month repayment, but the last payment is just upped a tiny little bit. Our next step in, and you've seen I've done a fair bit of pre-work on this one, our next step in analysing these loans is creating amortization tables. So amortization is using regular repayments to repay a loan over time. Okay, and an amortization table simply shows us the particular or the individual parts of that loan as we go through. So you see we've got our payments. We use this. We use an example where we borrow $10,000. Okay, and for that $10,000, what happens to that? Sorry, I think I should have. I've actually put $10,000. What it meant to be was $1,000. $10,000 is going to make all of those. There we go. $1,000 now. Get rid of my comma there. So we'll use $1,000, and with that, work out the particular parts of it. All right. So you'll see initially our initial balance is $1,000. That's how much we've got to pay. We're paying $257.85 each payment. So the first thing we can look at is how much interest is paid. Okay, so the interest paid is going to be the rate for the period, and that multiplied by the unpaid balance. Alright, so for instance, in this example, we can look at the interest paid, pop it in this box here, the one that's missing. If you want to, you can pause it and work it out yourself to start with. So we got, actually we'll have to work out the balance of the loan in that portion first to work that out, because we need the balance to pop the interest in. So the balance of the loan is balance take any reductions in the balance. Okay, so we would have 1,000 was our initial balance. You can see that the reductions in the loan there are 245.35. So our equation becomes 1,000 take 245.35, and that all equals 754 and 65 cents. So we can go ahead and pop that in there. 754. I'll redo that, it's a bit big. 754 and 65 cents. Now we can work out the rate. So now we can work out that interest column, which is the rate times the unpaid balance. So our rate, as we worked out, we'll use our last example. Our rate was 0.0125 multiplied by 754 $9.65. Okay. If you work that out, we get $9.43. So the interest paid here, $9.43. Then principal reduction, next step. So the principal reduction is given by the payment minus the interest paid. So payment, take away the interest paid. Because if you have the payment and you take away what you paid in interest, then the rest of that money is coming off the principal of the loan or that initial balance. Okay, so we'll look at this square here for the principal reduction. So you can see that we paid $257.85. A regular payment as before. And the interest we paid, as we just worked out, was $9.43. So the amount that our principal is actually, or what we owe is actually reduced by, is $248.42. So we can go ahead and pop that in here. $248.42. Okay, now that is lots of the information. We've still got a little bit to go. So on the next page, you'll see we've got the cost of repaying the loan. The cost of repaying the loan is just the sum of repayments. Okay. So the sum of repayments there, if we calculate the repayment amount, equals $1,031.44. Go back, pop that in. $1,031.44. Then the total interest paid, see that here, total interest paid is the cost of repayments and subtract the principal. Okay, so that'll equal the cost of the repayments was, as we said before, $1,031.44. Take away principal, so that's how much we took out the loan. So we took out $1,000, but we paid back $1,031.44. So all up, the cost of the loan to us is $31.44. So, which is just equal to the interest we paid. And you can see there, we've got a fairly detailed table on every part of the loan. The only thing that I've done wrong here, and I've just picked it up just then, on my notes it's different. This here should be a 9. Okay, so that should be 9. Because we know that earlier we changed that to a 9 to make sure that the total loan was paid off within 4 repayments. Okay, and you'll also notice that if you add up that column, this $1,031.44 is correct. Okay, sorry about that little hiccup. So that is amortization tables, as well as looking at the analysis of reducing balance loans with recurrence relation. So just skipping over it again, we've got the recurrence relation that we can write, which is similar to combining geometric growth and decay. Okay, so our relations there. And to recap that, we also have our amortization table, which simply takes all that information and looks at the interest paid, principal reductions, balance of the loans, how much you're paying, okay, and what the loan would look like over those 4 payments. So hopefully that makes sense. Pause, rewind, etc. If you need to go over it again, I think it's all fairly well described. Let me know if there are any improvements or any other things you'd like to know regarding this in either comments, etc. And if you think it's okay, give it a thumbs up. And like I said, if you need any improvements, throw those in the suggestions as well. Okay, so hopefully that gives you a bit of a all-round idea about amortization tables and analysing reducing balance loans. Cheers guys, have a good day.